Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, in the previous lecture we have learnt about the Heisenberg uncertainty principle. That principle stated that we cannot find the position and the momentum of electrons simultaneously. So by the establishment of Heisenberg uncertainty principle, the concept of orbit was abolished and the new concept of orbitals was accepted. According to this concept, we cannot specify the position of electron, but we can talk about the probability of finding electron in a specified volume called orbitals. So what is orbitals? It is actually the three-dimensional space around the nucleus where probability of finding electron is maximum. So let me write this thing first. By establishment of Heisenberg uncertainty principle, by establishment of Heisenberg uncertainty principle, the concept of orbit was abolished. The concept of orbit was abolished. What is orbit? It is the imaginary path around the nucleus on which the electron revolves. As we cannot find the position and momentum of electrons simultaneously, so how we can talk about the orbit? So that's why the concept of orbit was abolished. Then a new concept of orbitals was accepted, and the new concept of orbitals was accepted. Now, according to this concept, I'm writing, according to this concept, we cannot specify the exact position of electron, but we can specify the region around nucleus around the nucleus where probability of finding electron is maximum, where probability of finding electron is maximum. So now that region is called orbital. So let's talk about in the questionnaire form. I'm writing, the question is, what is orbital? What is orbitals? It is the three-dimensional space around the nucleus where probability of finding electron is maximum. I'm writing, it is the three-dimensional space around the nucleus where probability of finding electron is maximum. where probability of finding electron is maximum. Now, this approach of calculating the probability of finding electron in a specified volume was initiated by Sir Erwin Schrodinger in 1926 and developed a new branch of science called quantum mechanics. This approach of calculating probability of finding electron in a specified volume was initiated by Sir Erwin Schrodinger. Sir Erwin Schrodinger in 1926, and he developed a new branch of science called quantum mechanics. He developed a new branch of science called quantum mechanics. He has given a Schrodinger wave equation which describes the behavior of wave function associated with the waves of electron. What he has given? He has given Schrodinger wave equation which describes the behavior of wave function associated with the waves made by electron. Associated with waves made by electron. Now, let's derive the Schrodinger wave equation, and let's then talk about the proofs of existence of orbitals. Now, consider a stationary wave traveling in a positive x direction. The wave equation of this stationary wave will be, let me write this thing first. I'm writing consider a stationary wave. Consider a stationary wave traveling in positive x direction. The wave equation of the stationary wave, the wave equation of this stationary wave will be here I'm writing that's called psi, that will be equal to the capital A sine of 2 pi x divided by lambda, that is wavelength. So here, first of all, this is called psi, SIGH, psi, and this psi is called wave function. Wave function. Here x stands for displacement of wave along x direction. Displacement of wave along x direction. Here the capital A, that stands for amplitude of the wave. That so sorry my dear students. Here A stands for amplitude. A stands for amplitude of the wave, and the lambda, this lambda is called wavelength of the wave. So this is the different representations that I have written. That psi stands for wave function, x stands for displacement of wave along x direction, a is the amplitude of the wave, and this lambda is called the wavelength of the wave. So let's start derivation. I'm writing this equation again, that psi is equal to capital A sine of 2 pi x divided by wavelength. Now let's differentiate both sides with respect to x. Now d psi by dx will be equal to a cos of 2 pi x by lambda into 2 pi by lambda. Now in the next step, now let's square it. D square psi divided by dx square, that will be equal to a minus sine 2 pi x divided by wavelength into 2 pi by lambda into 2 pi by lambda. This thing turns out to be d square psi divided by dx square equal to minus 4 pi square lambda into a into sine of 2 pi x divided by wavelength and this thing. Now you can easily observe that a into sine 2 pi x by lambda is equal to psi, so you can substitute this value over here. So this thing comes out to be d square psi divided by dx square, that will be equal to the minus 4 pi square lambda into just psi. I hope you got this point. I have just substituted the value of a sine 2 pi x by lambda, that is equal to psi, and I have just substituted the value psi in the last step. Now let's talk about the wavelength. Here it was square, sorry, lambda square. Now 1 by lambda square, it comes out to be minus d square psi divided by dx square into 1 upon 4 pi square psi. Now let's talk about de Broglie equation in the separate panel. Here I am writing de Broglie equation. De Broglie equation. We know that lambda is equal to the h upon mv. Now on squaring both sides, it comes out to be lambda square equal to the h square upon m square into v square, or 1 by lambda square will be equal to the m square into v square divided by h square. Let's substitute the value over here. So this thing comes out to be then m square v square by h square is equal to the minus d square psi divided by dx square into 1 upon 4 pi square psi. Then finally m square into v square will be equal to minus h square upon 4 pi square psi into d square psi divided by dx square. Now let's talk about the kinetic energy in the separate panel. Here I am writing kinetic energy. I know that my kinetic energy is equal to the half mv square, or I can write it like 1 by 2 m square into v square divided by small m is the same thing. Now m square into v square is equal to the kinetic energy into 2m. Now let's substitute this value again over here. Now this thing comes out to be kinetic energy into 2m is equal to the minus h square upon 4 pi square psi into d square psi divided by dx square. Now kinetic energy comes out to be minus h square upon 8 pi square psi m into d square psi divided by dx square. Now let's talk about the total energy of the electron. Now we know that total energy will be equal to the kinetic energy plus potential energy. Now total energy will be equal to, let's substitute the value of kinetic energy from the above equation. It comes out to be minus h square upon 8 pi square psi m into d square psi divided by dx square plus potential energy. Now total energy minus potential energy will be equal to the minus h square upon 8 pi square psi m into d square psi divided by dx square. After that, let's cross multiply it. 8 pi square psi m divided by h square into total energy minus potential energy equal to the minus d square psi divided by dx का square. Or you can write like 8 pi square m divided by h square total energy minus potential energy equal into psi equal to the minus d square psi divided by dx square. Now in the next step, I have taken d square psi divided by dx square on the left hand side plus 8 pi square m divided by h square into total energy minus potential energy into psi equal to 0. This equation is called Schrodinger wave equation in one direction, that is x. So I am writing the above equation. The above equation is called Schrodinger wave equation Schrodinger wave equation in one direction that is x. This equation is Schrodinger wave equation, but in one direction x. So now let's write this equation for the particle or electron moving in the 3 dimensions. Now let's write this equation for the electron moving in 3 dimensions will be represented as d square psi by dx square plus d square psi by dy square plus d square psi by dz square plus 8 pi square m divided by h square into total energy minus potential energy into psi equal to 0. So that's the Schrodinger wave equation for the particle moving in 3 dimensions. This is the Schrodinger wave equation for the particle moving in 3 dimensions. Now, here the first three terms, that's the size d square psi by dx square plus d square psi by dy square plus d square psi by dz square. This is called Laplacian operator. This is called Laplacian operator, and it is represented by del square. That's the formula for representation for del square. This is called del square. It's a del square psi. So this is the Laplacian operator. The del square psi is the representation for the first three terms. Now let's substitute in this in the main formula. Now it becomes, the Schrodinger wave equation becomes del square psi plus 8 pi square m divided by h square into total energy minus potential energy into psi, it will be equal to 0. Now let's talk about the psi over here. So I'm writing from this equation, from this Schrodinger wave equation, my dear students, you have to find the value of psi. So I'm writing from above equation, we have to find the value of psi, that is wave function. Find the value of psi, that is wave function. Now when we will evaluate the value of psi, first point about the psi must be finite and continuous. I'm writing the psi must be finite and continuous. Second, The value of psi must satisfy the relation. Let me write that relation for you. I'm writing first of all, value of psi must satisfy the relation, and that relation is psi square into dv integration from 0 to infinity, and it must be equal to 0. When you will put the value of psi over here, your answer must come to be 0. Here this dv stands for small volume. This dv stands for small volume. Now I'm writing the values of psi. We are having various number of electrons per atom. When you will evaluate the different values of psi for different electrons, you will get the complete tabular form of different values of psi. You have to then put that values of psi in the above formula. By putting the different values of psi over in this formula, you will get the exact orbital of that electron. Now I'm writing the values of psi which is in accordance with above relation. The different values of psi for the different electrons. The values of psi which is in accordance with above relation with above relation are called Eigen functions. They are called Eigen functions. That values of psi will be termed as psi Eigen's functions, or in different way or in different words you can say that Eigen functions are called atomic orbitals. Are called atomic orbitals. That different values of psi that you are getting from the Schrodinger wave equation and which are following this equation, the psi square dv integration from 0 to infinity comes out to be 0. The values of psi that you have got from Schrodinger wave equation and following the above equation, that values will be called as atomic orbitals, or in other words they are also called Eigen functions. So here let's talk about what is the meaning of this psi square. Now let's talk about the psi square. My dear students, that psi square is a probability factor. Is a actually probability factor. And it describes the probability of finding electron within a small space called atomic orbitals. And this psi square describes the probability of finding electron, the probability of finding electron within a small space around nucleus called atomic orbitals. The value of psi will tell you about the atomic orbital, and the psi square will give you the probability of finding the electron within that small space around nucleus called atomic orbitals. So I hope you got this point. Let me tell you again. The above equation in green, that's a Schrodinger wave equation, and from that equation you have to evaluate the value of psi. And if that value of psi follows this equation, that psi square into dv integration from 0 to infinity comes out to be 0, that value will be termed as eigen function. That value of psi will be termed as eigen functions called the atomic orbitals, and the psi square is a probability factor. The psi square describes the probability of finding electron within a small space around nucleus called atomic orbitals. So that's all for today. I hope you all understood today's derivational point. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.